Hello, today we're going to talk about the zeros of polynomial functions, all right? Now, before we may have seen something like this where we have like three terms on a polynomial and we factor to find the zeros, but sometimes it's not that easy, and so we need to know a few tricks to get us to those zeros. But I'm going to ease you into this, and the first thing I want you to think about is not a black screen. Let me turn on the camera here. There we go. This function right here, and I want to know what are the zeros of this function. So let's find those out. Going back to our normal ways, we're going to say 1 times negative 35 is negative 35, so we are factoring here. And I want factors of negative 35 that add up to the middle term 2. It's going to be 7 and 5. One of them has to be negative. Our answer needs to be added up to be positive, so it's going to be that guy right there. 7 times negative 5 is negative 35, and 7 plus a negative 5 gives you positive 2. So I'm going to split this up. Actually, I can take the shortcut because the leading coefficient is 1 here and just say x plus 7 because that's a positive 7 times x minus 5 because that's a negative 5. These are what we call, remember, the factors, okay? Don't get the word zeros and factors mixed up. Zeros are where they cross the x-axis. Factors are the things I multiply to give me the polynomial. Put it that way. In this case, it's two binomials. So to find the zeros of the function, I'm going to say set the whole function equal to 0. And so that means either x plus 7 equals 0, or I've got x minus 5 equal to 0. And then I get negative 7 and positive 5. These are the things that make this right here written in blue go to 0. All right, notice if I put in 5, I get 25 plus 10, which is 35, minus 35 equals 0. Same thing with the negative 7. 49 plus 14, or sorry, 49 minus 14 equals 35, and 35 minus 35 is 0. Shouldn't be trying to do mental math today, I guess. So anyway, these are the zeros of the function. Let's work the other way around. What if I told you the zeros and said, come up with that function? How would you do it? Well, you'd say, okay, I've got negative 7 here and 5, which means the factors are those opposite values. So you should be able to jump from here and write this out right here. All right, so you got x plus 7. You can just move the 7 over, think of it like that, and you get x plus 7 equals 0. Move the 5 over by subtracting 5, you get x minus 5 equals 0. So these, you go from the zeros to figure out the factors. And then if you FOILed this out or multiplied it out, you would get the function up above. So that's what we're going to do in our next example here. I'm going to give you the zeros. Suppose you had zeros of 0 and negative 3. So x equals 0 and x equals negative 3. I want you to give me a polynomial function that has that for zeros. So here's our zeros. Let's jump to factors. So this is just x equals 0. So you can just write x as a factor there. And then move the negative 3 over, we get x plus 3. So these are the factors of this polynomial. Now multiply them out. X times x gives me x squared, and x times 3 gives me 3x. So here's our function. We can say y equals, if you want to, y equals x squared plus 3x. That is our function, and these are the zeros of that function. In fact, I use this trick a lot when I come up with problems in class. I'll start off with the zeros I want, and then make factors, and then make my polynomial so that students have to use the polynomial to find the zeros. Let's try another one. Suppose I wanted zeros of x equals negative 1, x equals 2, and x equals 5. So let's find the polynomial that has those for zeros. Doesn't mean it's the only polynomial, but easiest one for us. So I'm going to flip that sign, say, okay, x plus 1 is a factor, x minus 2 would be a factor then, and x minus 5 is a factor. And now I've got to multiply these out. So I'm going to say x times x is x squared, x times negative 2 is negative 2x. 1 times x is x, and 1 times negative 2 is negative 2. See, can I combine anything? Yeah, I can say this is the same thing as x squared minus x minus 2. So that's these two right there multiplied. Don't forget I got to multiply it by x minus 5 as well. So I'm going to once again go through all of this and distribute. X times x squared is x cubed. Running out of space here. That's x times x squared. X times negative x is negative x squared. X times negative 2 is negative 2x. And then I'm going to multiply everything by negative 5. So I get minus 5x squared. I'm just going to write it underneath the x squared term so I can easily combine them. Minus 5 times minus x gives me a positive 5x. And then let's see, negative 5 times negative 2 is positive 10. So adding the two functions up, I get x cubed minus 6x squared plus 3x plus 10. So this polynomial function right here has these four zeros, okay? So that's what we're dealing with. And now this one you might be able to factor easily. Let's see. Let's try doing this. What if we started with this? I gave you this on a quiz or test and said, find the zeros of x cubed minus 6x squared plus 3x plus 10. Could you come up with negative 1, 2, and 5 on your own? Because you're going to have to. So you say, okay, I'm going to try the old trick of just factoring this thing. So this is got 4 terms, so we're going to try factor by grouping here. We're going to factor out an x squared, and we get x minus 6. Now I need to, whatever I factor out here needs to match this parentheses right here. I'm not seeing where I can make that work. And so now we come into an issue here of like, how do we factor this thing? And that's what we need to solve today, is figure out how can we take something like this that we can't just factor to find the zeros and still find the zeros. And that's where our polynomial division is going to come in handy here. So let's go back to this x cubed minus 6x squared plus 3x plus 10. I'm going to write that down. We're going to come back to that once we learn how to solve it. And right now what I want to discuss with you is what we call the rational root theorem. That sounds fun, doesn't it? And what this says is this. You've got some polynomial function, and the possible rational zeros is equal to the factors of the constant term, and I'll explain what all this means here in a second, but we got to write down the technical definition. Factors of constant term divided by factors of the leading coefficient. Coefficient. I have to look to see how that's spelled. I'm still spelling it wrong, so just maybe I should write in cursive so you can't tell as easily that I'm spelling it wrong. So factors of the leading coefficient. Let me explain what that means here. Let's look at what we just talked about. We want to know what are the possible rational zeros. Now keep something in mind. When I say, breaking this down, rational meaning it has to be a rational number. All right, so a number that can be written as a fraction. We're talking about zeros, so the zeros of that function. So we're looking for the zeros. They've got to be rational numbers, and it's possible. It doesn't mean they are the zeros. So I'm going to write out the possible rational zeros. So I want the factors of the constant term. When we're looking at this, what is the constant term? It is the number 10. Notice it doesn't have a variable with it. It's what we call a constant, just a number, right? And it says to list the factors of that term. So what are the factors of 10? Well, you could say 1 times 10 equals 10. You could say 2 times 5 equals 10. You could say negative 1 times negative 10 equals 10, and negative 2 times negative 5 equals 10. These are all the possible, or these are all the factors of 10. Then it says to put it over factors of the leading coefficient. What is the leading coefficient here? The leading coefficient is a 1. So what are the factors of 1? We got 1 times 1 equals 1, and negative 1 times negative 1 equals 1. So I'm going to put these go in the numerator, over these. So let me show you what I mean by that. And I know what you're thinking, can we write plus or minus? Yeah, I'm fine with that. So you can say plus or minus, and they don't have to be in this order. I'm just going to go smallest to largest here. Plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Those are everything written right here, right? 1, 2, 3, 4, 5, 6, 7, 8, and 4 numbers there times 2 gives you 8. And then this is all over plus or minus 1. Sometimes we get a coefficient that's not 1, a leading coefficient that is not 1. In this case, we got it as 1. So what I just did was, because this is plus or minus 1, I just set myself up with the possible rational roots to this polynomial function. We could have just sat here and just divided this thing out with any old number I want. And there are a lot of numbers out there, right? But I've narrowed it down to 8 numbers. 1, 2, 5, and 10, or negative 1, negative 2, negative 5, and negative 10. Now, we know the answer because we came up with the actual equation, didn't we? What was the answer? We know the answer is negative 1, 2, and 5. Notice that 10 is not one of them. But that's why the thing's called possible rational roots. It helps you narrow it down. So how does this help us? Well, now we can say, you know what? Let's start with 1. What if 1 was a factor? Well, if 1's a factor, then it will divide evenly into that function. So here's where I'm going to use my synthetic division on this. Synthetic division says make sure that it's in descending order, and then we're not skipping over any x values. We got x cubed, x squared, x to the first, and x to the 0, so we're good there. Write down the coefficients. 1, negative 6, 3, and 10. Put this little thing right here, right? And I'm going to start with a positive 1 and see if that divides into it. Now, if it does, that means that x minus 1 is a factor and x equals 1 is a 0. Okay, keep that in mind, what's going on when we write positive 1 there. So I'm going to drop the 1, multiply, and add. Multiply and add. Multiply, did I add correctly there? Negative 2. Let's go back. Sometimes I go through this so quickly that I end up adding something incorrectly. Negative 2. Multiply and add. Notice my remainder is not 0. Okay? So that means that this is not a factor. So x equals 1 is not a 0. Let's try negative 1. Same thing here. 1, negative 6, 3, 10. Drop the 1, multiply, add. Multiply, add. Multiply, add. Well, that means that negative 1 is not a 0 either. Did we check and let's see here, make sure we got, it says negative 1 should be a 0. Let's make sure I got this correct. So 1, negative 6, 3, 10, drop the 1, multiply, add. Oh, you know what I did? See? I mess up too. And I'm not going to edit this out of the video. Teachers mess up, and I think it's important you see that sometimes we mess up when we're doing things. So 1, negative 7, that should be a positive 7, which makes this a positive 10, negative 10, and 0. So you say, well, Mr. Burnett, you would have gotten that wrong on a test. Probably not. All it does is I would have kept going until I found one of the other zeros and then factored it and then realized later on I messed that one up. You'll see what I mean here in a moment. But the key is this remainder is a 0, which means that negative 1 is a 0 to this function right here. You can even test it out by putting in negative 1 and you should get 0. All right. So what do we do with that? That means since x minus 1 is a 0, that means that x plus 1 is a factor. Okay. So when it's all said and done, what happens when I divide this function up here by x plus 1? Well, I get, remember we go 1 degree less, this is 1x squared minus 7x plus 10 is how many times x plus 1 goes into it. Or another way to say that is we've just factored it into x plus 1 times x squared minus 7x plus 10. So that's what we just factored it to. Now you could keep dividing this thing out using synthetic division if that makes you happy. It doesn't make me happy, you know. I think sometimes synthetic division can be a little taxing. It is fun, but if I can factor something, I'm going to factor it. So I've got 1 times 10 and factors of 10 that equals negative 7. Notice I'm taking what I got when I divided x plus 1 into this thing right here. When I divide it in, I got that right there left over after dividing it by x plus 1. So I'm going to factor that. That's what I'm doing here. So factors of factors of 10 that add up to -7. I got -2 and -5. Leading coefficient here is 1. So I can take the shortcut and say x minus 2 times x minus 5 times that x plus 1. That's all of that mess factored out, which means my zeros are -1, 2, and 5. So that's what we were looking for. We couldn't factor it from the beginning, so we used that possible rational root theorem to come up with our possible rational roots, and then we were able to factor once we divided it one time out. So like I said before, had I not caught that I made a mistake, I knew I made a mistake because I knew the 0 was -1. But let's say I messed that up, because that's going to happen to everybody at some point. Then we would have kept going and tried +2 and -2, +5, -5, and eventually that if we needed to. But what were our zeros? Our other zeros were 2 and 5. So hopefully I wouldn't have messed up 2 here. When I divided it with the 2, I would have realized, hey, 2 is a 0, and I would have gotten x minus 2 as a factor. And then up here at the top, it had been x minus 2 times some trinomial, and I would have been able to factor that and still found out later on, like, oh, x plus 1 was a factor, and realized I messed it up. All right, so that's why I include mistakes if I can, and that way you can see I make mistakes for one. I am human, and we can still overcome our mistakes if we're careful. All right, let's look at another one. So let's see. What example do I got for you here? Find the real zeros of problem number 3. We did that. Looking at my note guide here. Let's see. Find the zeros of this function right here. We've got 2x cubed plus 3x squared minus 8x plus 3. So this one, we can't just factor it by grouping. And I want you to find the zeros of that function. Now, on the quiz and on the test, a lot of times the directions are one of two things with these types of problems. One, I could ask you, just tell me what the possible rational roots are. So listen to the directions on that. Possible rational roots. If I tell you to list that, that's all I'm wanting, is what are the possible rational roots. You don't actually have to find the roots. But if I ask you to find the roots or the zeros, that's when you got to complete it out and find, first the possible rational roots, and then find which one of those are at the actual zeros, okay? So on this one right here, let's first start off by finding the possible rational roots. So I'm going to put factors of this over factors of this right here. Now, I think it's easy, and it helps out a lot of students to write out things like this. So I make this bracket, and this is what helps me figure them out, especially when they get to be larger numbers. Like if this were a 24, we'd have a lot of factors that go into 24 there. So it'd be a bigger mess here. So I'm going to write factors of 3 along this line right here. In this case, it's just 1 and 3. And then I'm going to write factors of 2 right here, 1 and 2. And this plus or minus reminds me I could have plus or minus 1 or plus or minus 3. And then underneath the bracket, I'm going to write 1 over 1, which is 1, 3 over 1, which is 3, 1 over 2, which is 1/2, and 3 over 2, which is 3/2. And just remember, these are all plus or minuses. This doesn't help out a whole lot on this particular problem, but when you get into, if this were a 24, imagine you'd have 1 and 24, 2 and 12, 3 and 8, 4 and 6. It turns out to be a lot of possible rational roots, and this will help you keep it organized if you do that. All right? So let's look at, so there's our possible rational roots written in green. If I was asking you on the quiz or test, just give me the possible rational roots, you'd write out these 4 things, right? Plus or minus in front of each one, and I would be happy with that. There are 8 possible rational roots here. But this thing wants you to find the actual zeros. So we have to go through and divide out, and hopefully we catch it early on. Before I set up my synthetic division, I want to make sure it goes x cubed, x squared, x to the first, x to the 0. So now it is ready to rock and roll. We can just set down the coefficients. And I'm going to start off with the easiest one, which I think is positive 1, and hopefully we get a winner there. So I'm going to drop the 2, multiply and add. Boom, look at that, winner. Let me just double check, because as you saw earlier, I make mistakes. Drop the 2, that looks good. Multiply, add 5. So these should match up, and it all looks good. So that means that when x equals 1, this whole thing equals 0. So x minus 1 is a factor of this. And when I take and divide that by x minus 1, this is the polynomial I'm going to get. I need to put some variables with it. So you go 1 degree less, x squared, x, and then it's just a constant term there. So it becomes this right here, 2x squared plus 5x minus 3. And if this seems a little weird to you, you can multiply them out and you should get the original polynomial up here. Now, that being the case, let's see if we can factor it now. 2 times a negative 3 is negative 6, and I want factors of negative 6 to add up to 5. Let's see here, I got 2 and 3. Those add up to 5. Let's see here, but I got to get them to multiply to give me negative 6. So if you make one of them negative, they're not going to work there. Let's try 1 and 6. Those multiply to give you 6. Let's make the 1 negative here. So negative 1 and 6 there, we can't take the shortcut because we've got a 2 right here. So that means we got to take this 5x and split it up into negative x and 6x. Notice negative x plus 6x is 5x. So I'm not changing the value of the function, just changing the way it looks. Now I can factor by grouping. There is an x in common here. That gives me 2x minus 1. Over here, there's a 3 in common. My light just went out, didn't it? So my light's powered by my computer, and my computer just went to sleep. There we go. Got it back up. So a couple of interruptions here. So if you see the video jumping, that's why. Somebody steps in the room or calls me or something like that. So with this being the case, let's see. Factor out that 3, and we get 2x minus 1 there. And we got x plus 3 times 2x minus 1. And then don't forget about the x minus 1 right here. Those are our factors, but they want to know what are the zeros of that function. So you're going to set each one equal to 0. So I got x minus 1 equals 0, x plus 3 equals 0, and 2x minus 1 equals 0. I'm taking each one of those factors and I'm letting them equal 0 to solve for it. So x equals 1, x equals negative 3, and x equals add 1, divide by 2, you get 1/2. Those are the zeros of this function. It's always a good idea, well, there's not going to be domain errors here, it's just a polynomial. So these are the zeros to this function right here. That's how we work there. I want to show you one more that's a little bit different and a little bit more involved. That's what you want to hear, right? Like, how can we make this take any longer? This one's going to be a fun one. So I want you to find all the real solutions to this right here. Negative 10x cubed plus 15x squared plus 16x minus 12 equals 0. Tell me what x values there will make that 0. So you can pause the video and try it if you want to, but there's a few tricks we're going to have to do to get us to the final solution. All of them you should know, it comes back from a long time ago. I'm going to set up my possible rational roots. Remember, we want factors of negative 12. So I know I got 1 and 12. I've got 2 and 6, and then I'm going to have 3 and 4, and these are plus or minus. Then the possible rational roots, not possible rational roots, the factors of negative 10. So I've got 1 and 10 and 2 and 5. So now maybe you can kind of see how setting up a chart like this might help you. So I've got 1 divided by 1, which is 1, 2 divided by 1, which is 2, 3 divided by 1, which is 3, 4 divided by 1, which is 4, 6 divided by 1, 6, and 12 divided by 1 is 12. That's pretty straightforward. It's exactly what's on top there. Then I'm going to divide everything by 2. So I get 1/2. That's 1 divided by 2. 2 divided by 2 is 1. I've already got 1 listed there. I'm not going to repeat that listing. 3 divided by 2 is 3/2. 4 divided by 2 is 2. I've already got that listed, so I'm not going to list it again. 6 divided by 2 is 3. I've already got that listed. 12 divided by 2 is 6. I've already got that listed. So no need to repeat those things. Now 1 divided by 5 is 1/5. Then 2 divided by 5 is 2/5. 3 divided by 5, 3/5. 6 divided by 5 is 6/5. 12 divided by 5 is 12/5. All of those are possible rational roots. 1 divided by 10 is 1/10. 2 divided by 10 is 1/5. I've already got it listed. And then I've got 3/5. 4 divided by 10 is 2/5, already listed. 6 divided by 10 is 3/5, that's already listed. 12 divided by 10, what does that reduce to? Well, you got what, 6/5, right? Oh, that's already listed. I don't need to list that again. Okay. Remember, these are all plus or minuses in front of them. That's what the plus or minus right here is to remind you. So if you're on a quiz or a test with me and I give you this and say, just list the possible rational roots, don't just list these. You know, you got to do the positive and the negative. Put a plus or minus in front of each one because otherwise you're only giving me half of the possible rational roots. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 positive rational roots, and then the negative values. We've got a total of 30 possible rational roots that would make this equal to 0. So hopefully in the beginning we find one that works. Otherwise we're going to be doing a lot of synthetic division until we find a winner here. So is this set up for synthetic division? It is. Let me write down the coefficients. So I got -10, 15, 16, -12. And I'm going to hope that we start with 1 and get a winner. So drop the -10 and add. Multiply and add, multiply and add. And was it 9, -9? So that one doesn't win. Try again. +15. This time I'm trying -1. So make sure you're flipping the signs. Adding that, let's see what we get. 5, 4, 9. And 9. Nope. That's sad, isn't it? Let's keep going. So that threw out +1 and -1. Let's look at 2. See, I know the answer, so I could cheat here, but I'm not. I want to show you that I also go through the pain of trying to figure out where my rational root is. So once again, -10, 15, 16, -12. Let's try +2 this time. Oh, look at that. I got 0. And it's good to double check. So here, drop the -10, double it, add them, double it, add them, double it, add them, and get 0. So that means 2 is a 0 here. So x minus 2 is a factor. All right. And then our degree originally was x cubed. That's what we started with. So this that's left over is going to be x squared, 1 degree less, and then x, and then plus 6. Now, does this factor? Well, we've got here factors of -60 that add up to -5. So we got 6 and 10, that's not going to add up to -5. 5 and 12, that doesn't work. 2 and 30, nope, not even close. 1 and 60, obviously not close. I don't see any factors here. In fact, I know there's not, okay, because I've done this problem already. Now, you could go through and keep dividing this out. And so keep in mind that an x minus 2 could be a factor again. So you got to start with 2 and do this and keep working. But we've got a lot of possible rational roots. The only thing we've completely eliminated is 1. we've got all of this still to divide out. So that could take a while. And because it's not factoring here, we could probably eliminate the whole numbers here and just go to these rational numbers down below and do all that. But that's not going to be pretty. It's a lot of multiplying and adding of fractions there. So remember, this is a trinomial or a quadratic in here, right? And so we can actually use the quadratic formula to figure out where we want to go. So with that being the case, we can say, okay, I've got quadratic formula equals x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So don't forget these tricks from your past, where this is a, this is b, and this is c. And so substituting in a negative 5 goes in, that gives me a positive 5, plus or minus the square root. Negative 5 squared is 25, and then minus 4 times a, which is 6, times c, a is negative 10, but it doesn't matter. Multiplication is commutative. 4ac, so I'm just putting the c first here, and then negative 10. All of this is over 2 times negative 10. And so let's see, 4 times 6 is 24, times negative 10 is negative 240, but negative 240, and we're subtracting, it's going to become a positive 240. And let's see, that gives me the square root, let's see, let's work this out. Where is my calculator? 25 plus 240, and I'm square rooting it, 5 plus or minus that, all over negative 20. So this becomes 265. Square root of 265 plus or minus 5 and negative 20. I'm just going to double check and make sure I'm on the right track before I take you down the wrong path. Yep, that's right. I'll just check and make sure. So we got square root of 265 plus or minus 5 divided by negative 20. I'm just going to use this space right here instead of going to a new piece of paper. And so we've got 5 plus the square root of 265 over negative 20. And then we got 5 minus the square root of 265 over 20. And here's a case where we don't use it much in this class, the calculator, but here's a case where we can use that, not natural log, get that off there. If I take the square root, so second, and then right above the square key is that inverse there, square root, 265, hit enter, and I get 16.27. So that's just the square root of 265. I'm going to add 5 to it, and then divide by negative 20 or negative 20, and I get negative 1.06 here. So this is negative 1.06. And then over here, I'm going to say, once again, square root of 265, hit enter, and then I'm going to say times this by a negative 1, because I'm going to say 5 minus that, and I've already started putting in this right here. So now it's a negative 16.27. Add that positive 5 to it, and then divide by, that should be a negative 20 still, divide by negative 20, and you get 0.56. Now I want to point out something at this moment here. The possible rational roots theorem is talking about the possible rational roots. Sometimes we have roots that are not rational numbers. And so it's not going to show up in our list, those 30-some, I think it was 30 we said, possible rational roots. Maybe it's not showing up on that. If we look at these right here, I don't think there are any fractions that equal negative 1.06 or 0.56. In fact, we kind of rounded those or truncated them off. I looked at them. I don't think there are any here. So these are probably not rational numbers that we're throwing in, because we are throwing away some stuff off the end on the decimals. And so the only way to really get to this is to first use our possible rational roots to find that rational root. And then the rest of it here, we're going to use quadratic formula to come up with some stuff we couldn't have come up with otherwise. So those are putting together some tricks that we've learned before. So we're combining factoring to find zeros. We're using quadratic formula to find zeros. And now we can use synthetic division to find zeros of a polynomial. Okay? I know that's a lot thrown at you. I'm going to give you a chance to do some practice problems. And I'll probably make another video of me just going through some practice problems with you, because I like to explain in depth and then later on come up with just practice problems for you to try out and let you see those also. Okay? Thanks for watching. I hope this helps. And as always, let me know if you have any questions. Okay? Goodbye.